Hello, Algebra 2. Today's topic is on day 4, graphing quadratics and solving by graphing. There's 3 learning targets today. Please make sure you write them into your notes. The first one is I can recognize the standard form of a quadratic function. The second one is I can solve a quadratic equation by graphing. And then the third one is I can describe the relationship among solutions of an equation, zeros of a function, x-intercepts, and factors of a polynomial expression. First, I want to make sure we review the vertex form from last class, and I want you to go ahead and graph number 1 and 2. See how you're doing on the last bit of material. Go ahead and graph number 1 and 2. I want you to state the vertex and axis of symmetry. Also, I added this part where I want you to state the transformations from the parent graph. So go ahead and graph them and add in also the transformations. So go ahead and pause the video and graph these two using your knowledge of the transformations and write in answers to these 3 questions. Okay, so first I would think about the transformations for this equation. And our transformations are right 2, and then our k is a -4, so it's down 4. So 2 transformations for my first graph. And so remember our parent graph starts at the origin. So if I go right 2 and down 4, this would be my vertex. So that point is 2, -4. And then our axis of symmetry, remember, is a line through the vertex, and it'll be a vertical line, so it will be x equals 2 in this case. Using our knowledge of transformations, we're going to take that shape of that parent graph that we're used to here at the origin and move it all the way to here, right 2 and down 4. So our vertex is here, and then we can, to get the rest of the shape, we can go right 1 and up 1, and then right, also you can go back to the origin, go right 2 and up 4, and left 1 and up 1, and then back to the vertex, left 2 and up 4. Okay, there's our new graph using transformations. Once you've graphed it by hand, you can then substitute this into the calculator to check. So you use the y equals x minus 2, make sure it's in parentheses, and then squared, and then -4. Our second equation has a of -1, so it's going to reflect horizontally. Then it has, it's moving left 1 because our h here is -1, so it moves to the left. And then our k is +2, so it moves up 2. So when we're thinking about when the a is -1, it reflects it down. And so instead of going up in this case, up 1 and right 1 and up 1, you're going to go right 1 and down 1 because we're going to reflect over the vertex. And then go back to the original vertex, the new vertex, and go right 2 and down 4. And back again to left. Instead of going left 1 and up 1, you're going to go left 1 and down 1. Left 2 and then down 4. Okay, so this shows how you would reflect our parent graph, because our a is -1. Make sure you draw your axis of symmetry through on both graphs. So x equals 2. Remember, it folds the graph in half, and our points can reflect on that. Okay, so you should have your vertex is negative 1, 2, and the axis symmetry is x equals negative 1. These two forms are quadratic functions are in vertex form. Today's notes are going to be talking about standard form. So our standard form of a quadratic function is when ax squared plus bx plus c, that's when our vertex form is FOILed out. So we could take this equation here and FOIL out our x minus 2 to get standard form. So we could multiply out x minus 2 times x minus 2 and then subtract 4 to get our standard form. So if I FOIL this, I'd have x squared minus 2x plus 4, and then minus 4. Then we can combine like terms. So x squared minus 4x, and then 4 minus 4 would be 0. So this equation is the standard form of number 1. Okay, so we can see the graph written, this equation written in vertex form or standard form. So standard form will have our quadratic, our linear, and our constant term. The a is the coefficient in front of the quadratic, and that's what makes it a quadratic. So a cannot be 0, because then it would be, if this was gone, we'd have a linear function. So we have to have a value of a other than 0 for it to be a quadratic. Our middle term here is our linear function, our linear part of the equation, where we have b times x, and then our c is our constant. It is our number without a variable. So some examples of a quadratic function. Let's just take 2x squared minus 5x plus 3. And it must be in standard form before you pull out the a, b, and c. So standard form meaning the x squared term is first, then the linear, and then the constant. So here our a is our number in front of the quadratic, so that would be 2. Our b would be negative 5. And then our c would be 3. I want you to go ahead and try these next two. Let's make these equations. So our number 2, let's have negative 3x squared plus 10. And this would be number 2. Number 3, let's call that negative 5x squared minus 2x. And let's go ahead and pause the video and fill these a, b, and c in. Okay, for number 2, we have our a. So a is our number in front of the quadratic, so it'd be negative 3. There is not a linear term, so when there isn't an x, it means it must have been 0 times x, so our b term would be 0, and our constant is 10. For number 3, you should have negative 5 for a, that's our number in front of the quadratic term, and our b is negative 2, so our number in front of x. This time our c is not existing, so the only thing we can add to this equation is 0, so our c is 0. Okay, so we can graph a quadratic function with a table. And remember from last class, we call the graph of a quadratic function a parabola. Let's use a table to graph this function. Go ahead and use these x values to substitute into this equation and see what y values you get. Then go ahead and plot your graph on this coordinate plane and see if you can come up with your parabola shape. If you need to, add other values to help you do that. When you substitute in -2 to your equation, do you substitute that -2 into both x's here? Also, make sure you use parentheses when you substitute in. So when you do that, you'll get -2 squared would be 4. 4 times 2 is 8. Then you have plus a -8 plus 1. So your y value when x is -2 would be 1. You would then substitute in -1 in for x, both x's, and you get -1 for your y value. When you substitute 0, you get 1. 1, you get 7, and 2 is 17. So once you have some points to substitute in your graph here, plot, you can start to see your shape. So it turned out my vertex was at -1, -1, and we could start to see the symmetry of the parabola when we had the same two y values, so 0, 1 and -2, 1. The other points, 1, 7 and 2, 17, we can use just to confirm the shape that we are getting and realize the axis of symmetry would help us plot and find other points. So we know that it would have to fold on this and over. So if there's a point at 1, 7, we would have to have that same point over here at -3, 7. Okay, so little tidbits. These rules will help you when you have a quadratic function in standard form. The y-intercept turns out to be the constant, because if you substitute in 0 for both x's, you're going to get c. So it's going to be the constant term. So our y-intercept will be c. 0c, whatever that constant term is. The equation of the axis of symmetry will be x equals -b over 2a. And we'll be talking more about where that comes from when we talk about the quadratic formula. And since the vertex is a point, then the x-coordinate of the vertex is -b over 2a. And therefore the vertex would be -b over 2a, and the value of the function at -b over 2a. So once you know the x value of the vertex, remember you can always substitute that into the equation. So this is just that function notation. So we substitute in the x value into the function to find the y value. Alright, so our graph is going to look like when a is greater than 0, it's going to go up. It's our parabola going up. It'll have a minimum. And when our graph is less than 0, so our a will be negative, it's going to go down. So we'll have a maximum. Okay, the last part of the video is I want you to skip to the third page and the bottom section of the third page and make sure you understand that the quadratic equation is a quadratic function that's set equal to a number. So we can solve our quadratic equations by setting equal to 0, and we always want to do that when we're going to solve. We set it equal to 0, and solutions to the quadratic equations are x-intercepts, roots, or zeros. So these are your solutions.